This video will be an overview of section 10.1, Graphs and Graph Models. By the end of this section, you should be able to draw graph models for various applications and identify the kind of graph from Table 1, which we'll show you in this video, used to model various applications. Now, this first section is an introduction to graph theory. And basically, in this section, there are a lot of definitions that should be very easy for you to understand. And at this stage of the course, it will be helpful for you to read the slides on your own, and you should be able to interpret the slides on your own. So during this video, instead of reading the slides to you, I will quickly scan through them to show you sort of what the slides cover, but then it will be your responsibility to go on to Moodle and read through the slides, read the definitions, look at the examples, and try to interpret and understand them yourselves. Of course, if you do have any questions, then you can post them to the forum on Moodle or ask them in class, and I would be happy to answer your questions. Okay, so first there's a definition of a graph, and as you can see, the graphs we're talking about in graph theory are very different from graphs of functions that you may be aware of. And so you can read through the definition of a graph to understand what it means and how this particular example satisfies that definition, including the details that are here. And then there are extensive terminology for you to learn, and instead of me reading each of these things to you, I think you should be able to read them yourselves and interpret them. And these specify different types of graphs, which we'll talk about when we get to Table 1. And then there are another category of graphs called directed graphs, which will be helpful for us when we look at the graph models and applications of graphs and associated terminology with those types of graphs. And finally, we'll also look at graph models. In particular, we will use these graphs to model computer networks and other types of relationships between objects in different capacities. And we'll identify each of the different capacities we'll be looking at. So you can see here, basically, the vertices specify different cities in the United States, and the edges, in the case of these graph models denoting computer networks, show the computer networks connected between these cities in the United States. And if you read through these examples, you will get a better understanding of how graph models are used, and there are a number of different ways that graph models can be used to specify depending on the type of model we're looking for and the kind of information we want to demonstrate in the model itself. So this one is very similar to the one before, except now we have what are called multiple edges between vertices because there are multiple data centers connected between each of these cities within the United States, as you can see here, and so that's used by a multigraph. So as you can see, I'm using a lot of the terminology, so it's very important that you do read through the notes to get a better understanding of what each of these terms mean. In some cases, there will be data centers connected to each other within the same city, and so we use loops in a pseudograph to identify this. And finally, in the case of directed graphs, a direction is identified here. So there's a link going in a particular direction between each of these data centers in these cities. Okay, so after you have developed the understanding of what a graph is, the various terminology, and are starting to look at various graph models, there are a number of questions you need to ask yourselves in order to determine exactly which graph will be used to model the situation you're looking at. So the first question to ask is, are the edges of the graph undirected or directed or both? So does the direction of the relationship between the vertices matter or not? Whether the edges are undirected or directed, will there be multiple edges present to connect the same pair of vertices? So are there multiple relationships happening that need to be identified through edges connecting those vertices. And are loops present? Is an individual related to itself in any way? And so table 1 from the textbook identifies the different types of graph we have, so be sure you go back and review the notes to identify what the definition is of each of these types of graphs. But then you can see as we answer each of these questions, it identifies which type of graph would be used as your model.